Hello guys, welcome to my channel Algorithm Avenue. Since our previous videos, we have been discussing about the different types of stochastic gradient descent algorithms. The first gradient descent algorithm that we have discussed is batch gradient descent, and we have also seen the problems with batch gradient descent. And the second gradient descent algorithm we have seen is stochastic gradient descent algorithm, and we have also seen the problems with stochastic gradient descent algorithm. Now let's in short see the problems with stochastic gradient descent algorithm. The first problem is inconsistent. Okay, it is inconsistent. Stochastic gradient descent algorithm is always inconsistent. Let's say you have a data set. Okay, let's say you have a data set and you have trained your data set on stochastic gradient descent, and you have got some fixed trainable parameters as output. Okay, you have got some fixed trainable parameters as output, and another time when you retrain your data set. Okay, when you retrain your data set on the stochastic gradient descent algorithm for the same data set. Okay, for the same data set, it again outputs some another set of trainable parameters. Okay, first time when you train your data set on the stochastic gradient descent algorithm, it has produced some fixed trainable parameters. Again, when you retrain your dataset on the same stochastic gradient descent algorithm, it outputs another set of another set of trainable parameters as output. Means each time you retrain your data on the stochastic gradient descent algorithm, it maintains some inconsistency. Okay, it maintains inconsistency in the output. Okay, it produces, means it outputs different set of fixed trainable parameters for each time when you retrain your data set on stochastic gradient descent algorithm. Okay, this is the first problem with stochastic gradient descent algorithm. Now let's see second problem that we face while implementing the stochastic gradient descent algorithm is randomness. Okay, it is much random. Stochastic gradient descent is much random. Let's understand it with contour plot. Okay, this is the contour plot, and this is the contour plot of stochastic gradient descent. Okay, this is the global minimum point. This is the global minimum point. When you start from here, you see that it is taking much random steps. Okay, it is taking much random steps to reach the global minima. Okay, due to this randomness, it consumes lot of time to converge to the fixed output, to converge to the global minima. This randomness is called noise. Okay, this randomness is called noise. Okay, due to this noise, the to converge to the local minimum point, it is consuming lot of time. Okay, this is the second problem with stochastic gradient descent algorithm. The first problem is inconsistency, and the second problem is randomness. Okay, these two problems are overcome by mini batch gradient descent. Okay, this inconsistency and randomness are overcome by mini batch gradient descent. Okay, as the name suggests, mini batch means you are dividing your data into mini batches. Okay, you are dividing your data into mini batches. It is in the middle of stochastic gradient batch gradient descent and stochastic gradient descent. Okay, it is in the middle of batch gradient descent and stochastic gradient descent. Means the batch gradient descent, it solves the problems of batch gradient descent and stochastic gradient descent. Okay, now let's see a small example on how this mini batch gradient descent algorithm actually works. Let's say you have 1,000 rows of data. Okay, let's say you have 1,000 rows of data, and you have taken batches of 100. Batch size is equal to 100. You have 1,000 rows of data, and the batch size is equal to 100. Means each batch contains 100 rows of data. Means it uh, it uh, it uh, it suggests that 10 batches. Okay, each batch size is 100. It means this 1,000 rows of data is divided by 100, which corresponds to 10 batches. Okay, which corresponds to 10 batches. Okay, this is the division of mini batch gradient descent. Okay, if the batch size is 1, if the batch size is 1, then it is stochastic gradient descent. If the batch size is 1,000, then it is batch gradient descent. Okay, when the batch size is 1, means you are training each sample. Okay, you are training each sample individually. That corresponds to stochastic gradient descent. When the batch size is 1000, means you are considering 1000 samples as a single batch. 1000 samples as a single batch means that corresponds to batch gradient descent. Okay, in this way division is done in mini batch gradient descent. Okay, now let's see how actually we train mini batch gradient descent. Okay, how actually we train our data with mini batch gradient descent. Okay, let's say we have same samples. Okay, we have same 1000 rows of data, and our batches is 100. Batch size is 100, means each batch contains 100 samples of data. Okay, now what initially happens is, first this 1000 rows of data are randomly shuffled. Okay, randomly shuffled. Let's say we have xyz. Okay, xyz as a row. Let's say this is our first row of this 1000 rows of data. Okay, this is our first row of this 1000 rows of data. Now when you randomly shuffle your data, this first row either becomes 99th row or 106th row or either 999th row. Okay, in this way random shuffling is done before implementing the mini batch gradient descent. Okay, before implementing the mini batch gradient descent. Now after this random shuffling you divide your data into mini batches. Okay, you divide your data into mini batches. Okay, in each batch you'll be having equal number of samples. Okay, remember, in each batch you'll be having equal number of samples. Let's take this as an example. When you have 1000 rows of data, you divide each sample. Okay, sorry, you divide your 1000 rows of data into 10 different batches, means each batch contains 100 rows of data. Okay, this 100 rows of data represents each batch contains equal number of training samples. Okay, equal number of samples. Okay, after you divide your data into mini batches, how the training is done is, okay, let's say batches is equal to 10. Let's say batches is equal to 10. After dividing your data into 10 different batches, 10 different batches, what happens is each time. Okay, each time you okay each time, let's say for the first batch. Okay, we have 10 batches, right? For the first batch the parameters are updated, and for the second batch the parameters are updated, and for the third batch parameters are updated. Means in each epoch we update 10 times. Okay, we update 10 times the parameters. Okay, we update 10 times the training parameters. Okay, when you 8 9 10, let's say we have 10 different batches, right? Now in each epoch for the first batch we update the training parameters, and for the next batch we update the training parameters, and for the third batch we update the training parameters. It means we have 10 batches, right? We update the parameters 10 times. Okay, means the number of batches corresponds to number of times you update your trainable parameters. Okay, in the first gradient descent algorithm, that is batch gradient descent, you consider your 1000 rows of data as a single batch and update your trainable parameters single time. In the second gradient descent algorithm, that is stochastic gradient descent algorithm, you consider each row as your training sample. Okay, each row as a single batch, and you update your parameters 1000 times. But when it comes to mini batch gradient descent, you're considering 100 rows of data, 100 rows of data as a batch. 100 rows of data as a batch means that corresponds to you're updating your parameters 10 times. That is total number of batches. Okay, that is total number of batches. Now let's see different cases in this weight updation. Okay, now let's see different cases for this batches division. In the first case when you have time series data. Okay, in the first case when you have time series data, that means you cannot shuffle your data. Okay, that means you cannot shuffle your data. in time series data sequence matters. Okay, the second row of data is dependent on the first row, and third row of data is dependent on the second row. Means each row is dependent on the one another, so you cannot shuffle your data in case of time series data. Time series data is not shuffled. Now let's see the another case. Let's say you have 1001 rows of data. Let's say you have 1001 rows of data, and your batch size is 100. Okay, you have 1001 rows of data and your batch size is 100. Means when you divide this batch size with total number of rows, you will be getting number of batches nearly is equal to 10. Okay, number of batches are nearly equal to 10. Means it is something around 10 point something. Okay, 10 point something, it is nearly equal to 10. Okay, you see that you are ignoring one row. Okay, you see that you are ignoring one row. So to avoid this there are two approaches. Okay, to avoid this there are two approaches. First is dropping, and the second is padding. As I have already specified, each batch contains equal number of samples. Okay, each batch contains equal number of samples. But in this case, you see that one sample is left over. Okay, one sample is left over. So to handle this single sample, we have two approaches. First is dropping, and the second is padding. That means either you drop the single row, and the second is padding. Means what you do here is, as I have specified, you have 10 batches. Now you need to make this 10 batches as 11. Okay, you need to make this 10 batches as 11. Okay, why do you make this 11 is because to consider this single row, the leftover 99 rows are filled with zeros. Okay, to consider this single row of data, okay, you are feeling this single row of data is much important to you. So to consider this single row of data, the leftover 99 rows of data are filled with zeros. Okay, are filled with zeros. So this is called padding. Okay, this is called padding, and this is called dropping. Okay, mostly in this cases, you definitely drop that single row. Okay, you definitely drop that single row. Let's say you have 1005. Okay, you drop that five samples. Okay, you drop that five samples and move with the leftover 1000 rows of data. Okay, now let's see the third case. Let's see the third case. Let's suppose say you have 1098 rows of data. 1098 rows of data. Same batches is 1000. Batches is 100, and the number of batches you'll be getting is 10 point something. And you round it off to 11. You round it off to 11, and the leftover two rows of data, you will be having two rows of data left. Right? Means in this 1098, we have divided each batch 100 rows of data into single batch. Okay, 100 rows of data into single batch means we'll be getting nearly 11 different batches. Okay, in the 11th batch you will be having 98 rows. Okay, the leftover two rows are padded. Okay, the leftover two rows are padded. Okay, instead of dropping this 98 rows, means you are dropping the entire you're dropping the distribution of your data. Means if you drop this 98 rows, you're losing a lot of information from your data. Okay, so to avoid this, you do padding. Okay, to avoid this, you do padding. Means two rows of data are filled with zeros. Okay, these are the three cases. Okay, these are the three cases in applying the mini batch gradient descent algorithm. The first is time series data is not shuffled, and the second is when you have this kind of data. When you have this kind of data, you mostly drop the row. Okay, you mostly drop the row. And in the third case, when you have your data in this way, 1098, you mostly pad the data. Okay, you mostly pad the data. Okay, these are the three cases in case of mini batch gradient descent. Okay, to summarize, in mini batch gradient descent, you update your parameters. Equal to the total number of batches. Let's say you have total number of 10 batches, means that corresponds to you are updating your parameters, 10 times. Okay, you are updating your parameters 10 times. This is the entire intuition of mini batch gradient descent. Okay, so till now we have completed different types of gradient descent algorithms. In our upcoming videos we'll be discussing about the back propagation algorithm, which is very important. Okay, which is very important. So just to understand the back propagation algorithm, I have entirely discussed about this gradient descent algorithms. Okay, hope you definitely watch my next video. Okay, even this video is also much important. Okay, hope you like this video. If you like the video, please like, share and subscribe. Thank you.